Okay. Welcome to the TYPT 2022. This is the first round for the competition, and in this round there will be detonation, axial fire, and rock cha-cha, 3 teams to compete with each other. And let me first introduce the duo, starting from me. My name is Liu Long, come from 台湾师范大学 and
张明国的欧洲版师范大学。去年那些参加是中山大学。
I'm Gochu from South High School.
Okay, my name is Yang Jiahui from Fengjia University.
Thank you. And now the team leader to introduce yourself, starting from the reporter.
Hello everyone, I am the team leader of Team Detonation, and my name is Li Yifen. Thank you.
Would you like to introduce your teammates?
Our teammates, sure. Our teammates are Xie Haoji and Hong Weixiang, Lin Yihui, and Li Senzi.
Okay. And the opponent?
The team is Bill, and I'm the captain Liu Yushen. Here are my teammates, Chen Yihong and Fei Xin, Zhongzhan, Wei Yue.
Okay. And the viewer?
I'm Team Chacha, and I'm Liu. I'm the leader Liu Hinsen, and this is Chen Ankai, Wang Yanhua, Yixun Liu, and Xin Yan.
Okay. Okay. So, if everything is fine, then the opponent, would you raise your question to challenge the reporter?
The opponent wants to challenge problem number 6, tennis ball tower.
Problem number 6.
Yes, we accept.
Okay. So, with all the representatives, write down your names on the floor, on the blackboard.要记录题号，你们没有要记录题号吗？你要把题号写在，跟你觉得题号写在，应该是不用吗？
他们要写。
Please take the stage.
Honorable judges and worthy opponent, I'm the reporter of Province 6. Today I'm going to present tennis ball talent. So first, here's our outline. So first, we are going to start with problem statement and then its phenomenon. And next, we are going to using our theoretical model to analyze the phenomenon. Next, we are going to conduct an experiment by stacking up the tennis ball tower in reality. And lastly, we are going to summarize and conclude it. So first, here's the problem statement. The problem statement tells us to use 3 balls per layer and a single ball on top to build a 3n+1 form of tennis ball tower. And also, it wants us to investigate the structural limits and the stability of such a tower. And also, we need to find a suitable number of the balls on the top layer when the situation changes when more than 3 balls per each layer. So our main focus will be study the limits of the structure, and also we're going to find the angle between the contacting point, and also we're going to find the height limit of the tower. Lastly, we're going to discuss different situations when the number of balls change. So first, I'm going to introduce how to build a 3n+1 tennis ball tower. For example, if we want to build 3 layers of this form of tennis ball tower. For the first layer, we need to shape 3 tennis balls into a triangle. And for the second layer, we also need to shape 3 balls into a triangle, but it is in an opposite direction. And for the top layer, we will need to put a ball in the center. And we're starting our analysis with 2 layers of this tennis ball tower. So it is a tetrahedron shape of the tower. And we are using the equilibrium of forces and torques, and therefore we can come to these formulas, which means that if we know the weight of the ball and the theta, which is this angle, we can get to know the friction. And next, we're going to after knowing the friction and the normal force, we can calculate the coefficient between the court and the tennis, and also set up between 2 tennis balls. So because we're assuming it is an idealized situation, so the balls will be tightly connected to each other, but won't cause deformation. So therefore, the theta is equal to 60 degrees. And so the cosine theta will be 1/√3. And therefore, we can calculate the value of mu1 and mu2. Next, we're going to discuss this tennis ball tower from the 2 layers from bottom. So before we dive into our theory, we have to define several variables. So let's take a look at this 3D model. F2 is the friction, is the joint force of the 2 frictions that the gray balls gave the green one. And the N2 is the joint force of the 2 normal forces that the gray balls gave the green one. And after defining these 2 variables, let's take a look at the ball figure on the right side. N1 is the normal force that the ground gave the green ball. And the F1 is the friction that the ground gave the ball. And the angle theta is formed by N2 and vertical axis. And angle phi is formed by N2 and F2. So now let's dive into our theory. So in our theory, we'll start with the torque equilibrium. So because we used a simulator to create this 3D model, so we can get to know that the phi will be equal to 105 degrees. So therefore we can list out the torque equilibrium as follows. Next, we are going to discuss the force equilibrium with horizontal one and vertical one. So So we can get to know the normal force 1 and normal force 2 by the number of balls and the weight of balls, which is as below. Next, we're going to calculate its friction force by as following. So first, we're going to use the vertical equilibrium formula we mentioned before and the value of sine phi and sine theta, which we get it from simulator. So after using these variables, we can get the value of F1 and F2. So for example, if n is equal to 2, the F2 will be near to 0.785, and therefore we can get the F1 by using the sine phi and F2. And after getting the value of friction and normal force, we can get to know the coefficient of friction, which is mu1 and mu2. And because we're setting this in an idealized situation, so mu1 and mu2 will be constant while we building up this tennis ball tower. And now, next we're going to discuss the changes in angle. So after calculations, we find that if n is equal to 13, the tower will reach a status of torque equilibrium, but an unstable equilibrium of force. It means that the tower will be unstable, and therefore we assume that the critical value of the collapse is it can be defined by sine, and sine is between the 0.601 and 0.598, when n is equal to 12, the tower won't collapse, but if it is equal to 13, it will collapse. Next, we're going to introduce our experiment equipment. So first, we need a tennis ball, and next we need a scaffold to stabilize our tennis ball tower while we're building up them. And also, we will measure the coefficient of friction by using the coefficient of friction measuring device, which we stick the skin of tennis ball on the wooden board. And also we will need the weights to control its normal force. And lastly, we'll need a spring balance to measure its friction. So here's the tennis ball that we have built. And we find that the tallest towers that we can build is 6 layers. So which deviates from our theoretical assumptions. So therefore we find the relationship between the normal force and the coefficient of friction. So therefore we can come to an empirical formula, which is y is equal to 1 minus 0.231 natural log x. And y is coefficient of friction, and x is normal force, which is as the graph shows. Next, we are going to discuss, we are going to further analyze this phenomenon. So by using these equations we mentioned in our theory, we can get to know the sine phi of different layers of the tower. So when n is equal to 6, it is lower than our critical value, so it will collapse. And therefore, the 6th layer is the maximum, which fits our results. Next, according to problem statement, we have to build a tennis ball tower that has different numbers of balls each layer. So therefore, we built a hexagon triangle tower ball tower. And for example, if we want to build a 3-layer of this tower, the first layer we have to put the 7 balls into a hexagon shape, and the second layer we have to put 6 balls into a triangle shape, and for the top layer we will need 3 balls. And here's our analysis. So after calculating the sine phi of each layers, so we can find that the critical value that we defined earlier is between the 4 and 5, which means that if we build to 5 layers, it is the maximum of this height. And when it is 6 layers, it will collapse. So here comes our summary. So first, we found from our experiment in theory, we find that it is the friction that keeps the tower state equilibrium because it won't be stable without the friction given by the top ball and the friction given by and the downer ball. Also, the coefficient of friction will decreases when the normal forces increases, and we think it's because that the surface of the tennis ball, because as the weight increases, it will flatten the fur on the skin, and maybe it will make it easier to slip away. Also, lastly, in real world, the height limit of 3n plus 1 tower is 6 layers, and the hexagon triangle tower is 5 layers, according to our experiment and our further analysis. And next, lastly, it comes to our conclusion. So first, our theoretical models dealt the structural limits of skirting layers for 3n plus 1 tennis ball tower, but the real model is actually 6 layers, and we think that it's because the change in the coefficient of friction, which we have graphed it out. And lastly, we think that the reason for collapse has main 2 reasons. First, it is the angle. If the angle is greater than a critical value, the tennis ball tower will collapse. And also, it's because the top layer, the top ball that gives the friction to the downward ball to make this stabilize and reach the equilibrium of forces and torques. And here's our references. It is the end of my presentation. Thanks for listening.
Okay. The opponent? No question.
Okay, first, is friction coefficient between the ball the main limitation to make the tower stable?
Yes.
And is the friction between different layers the same?
No, because the downer balls will support the upper balls, so it
Okay,
will.
thank you. Is the normal force proportional to friction in every layer?
Yes.
Okay. Is the tennis ball tower stable when it is stacked with no gap between the balls?
Yes.
And did you consider it as a no gap between balls in your theory?
Yes, in our theory, we think it is an ideal.
Okay, thank you. Is the tennis ball in the same layer giving the normal force beside the ball?
No.
Okay, did you consider the tower as 3-dimensional?
Yes.
Which friction coefficient of tennis ball do you think affects the most?
Yes. We think it's the coefficient
Okay. The friction coefficient of bottom or between the table?
I think it is the coefficient between the balls.
Okay. When the tennis ball tower is stacked higher, will the angle change with different layers?
Yes.
And how will it change?
It will, as we stack up higher, the phi that we defined earlier will become greater as to stabilize.
Okay, thank you. Did you consider the tennis ball as a rigid body? It won't cause deformation, right?
Yes.
Okay. Do you have the limit of its height in your theory?
Time's up. The opponent, you have 3 minutes to prepare your talk. Okay, opponent.
Honorable jury's fellow competitors, this is the opponent from Team Excelsior, opposing problem number 6, tennis ball tower. Build a tower by stacking tennis balls using the 3 balls per layer and a single ball on top. Investigate the structural limits and the stability of such a tower. How does the situation change when more than 3 balls per layer and a suitable number of balls on the top layer are used? And our main focus on what forces makes the structure stable. And the opponent believes that the friction coefficient might be an important factor to influence the stability. And last, due to the problem statement, to investigate the structures of more than 3 balls per layer. The opponent believes that the structure of solving problems could be separated into 3 parts. First, analyze the force in the structure, which I think the main forces that acts in the tennis ball tower might be friction, normal force, gravitational force, etc. Then, investigate the friction coefficient that affects the stability of the tower, and this which would affect the gap between balls. In this part, the opponent believes that we should consider the minimum strain energy that would cause deviation when calculating. Last, due to your problem statement, how the different parameters such as friction coefficient, each ball per layer affects the stability of the tower. These are strong and weak points that the reporter had. First of all, she had a clear model of tennis ball tower. However, she cannot control the initial condition of the tower block, and her angle, since her angle was calculated by the simulation, she did separately calculated every tennis ball's force, and in her theory, there's a measurement of friction coefficient. However, she can predict the structural limits. However, she didn't consider the normal force between the same layer, and she didn't consider the deformation and gap between the balls in theory. And last, she didn't consider boundary condition between different layers and between the ball and the table, and focus on the structural limits. These are the points that I want to discuss on. First, I want to discuss about force analysis. Because that the tennis ball is an item with weight, so a gravitational force should be caused in the structure pointing downward. And because that inside the tennis ball tower, there are multiple contact points with the tennis between different layers and also between tennis balls. So the opponent thinks that friction might act on these multiple contact points. In this part, I want to discuss about the static friction coefficient and the direction of friction. Next, about the normal force. The normal force may not only caused by the supporting of gravitational force. I want to discuss about if the normal force acts between the balls in the same layer. And I also want to discuss about the direction of normal force. And in this part, the minimum energy should be considered inside the normal force, which it would cause the difference of friction coefficient. And when the friction coefficient is different, it will change the boundary condition and cause a deviation such as gap between the balls difference. Last, due to your problem statement, the opponent believes that the tennis ball we should investigate the friction coefficient and mass, which would affect the friction of the tennis ball. And to discuss about different structures, about how each ball per layer, amount of layers, and more structures, how will they affect the stability of the tower? Thank you. I would like to skip to the next phase.
Sure. Please.
Okay, so first, how did you define stable or unstable?
just as I mentioned in our theory.
Did you define it as will it collapse or not?
We defined by it whether it has reached the equilibrium or not.
Okay, and what is the boundary condition of the amount of layers?
We didn't consider it.
Okay, may I use a blackboard?
Sure. Go ahead.
So, in the tennis ball tower structure, and can you draw the direction of friction and normal force between the centroid of between this ball? Can you draw the direction of friction and normal force?
So for the and you mean the friction that gives this wall?
That is around this ball.
Okay. So first,
Is this the friction or normal force?
it is.
So first talking about the so the opponent believes that this the friction should act in these two ways, and also these two ways because there are contact points in these 4 points, and do you agree with that? And so can you tell me what is the included angle if we set this as phi 1? Can you tell me what is the magnitude of this angle when you think of it as a 3-dimension?
Are you mean that it is in real scenario or it's idealized?
An idealized.
We didn't did a calculation on this, but we have stimulated this tennis ball tower, so but we didn't use this angle in survey, so we didn't actually compute.
And then do you think that if this is phi 2, do you think this is the same?
Yes.
The opponent believes that it wouldn't be the same since when you're calculating the torque of friction, you can thought of it as F1 times cos theta times cos theta 1 times R, which means the torque of friction 1. And for the same as the friction 2, it could be considered as this. And since they both have the same radius inside the formula, because it has the same radius in the tennis ball, so and also they have the same theta. However, you mentioned that when there are multiple layers, the friction, the normal force and friction would be larger when it's low in the lower layer. Did you?
But it seems that this friction and this friction were equalize each other. So sorry.
I mean, do you think that this friction and normal force is bigger than this one?
It means that the normal force is bigger than this.
The friction of these two balls. Do you think that it would be effective? You just mentioned that in lower balls, it has greater normal force in the short crushing.
Yes.
Okay, so but you just said that these two are the same, which means that the friction of F1 and F2 is the same. So therefore
the angle that I talked about is the tetrahedron shape, and yes.
Okay, so the opponent believes that the phi1 would be smaller than phi2, so that the torque of F1 would be smaller than F2, because when you are having more layers, then the gravitational force increases for the lower layer, so it will have greater normal force and friction. Do you agree with that? Okay. And about the do you think that when it's in the same layer, the normal force acts between the balls in the same layer?
No, there's no.
And how can you prove that?
Because we're getting this. We are discussing these idealized information. So the forces is between the different layers.
But however, the opponent believes that you should consider the normal force that acts between the same layer, or you should try to prove how it's different, because there are contact points in this.
It says that the normal force is pointed out because
So when
the forces will push it out. So
but when you think of this as a spring, which you can thought of that F equals to K dot X, and when you do the determinant of this equals 0, because when you are calculating, you know that there are three functions, which is the horizontal force, and also the vertical force, and also the torque. Then, if you consider that there are normal force inside, which I think you should, because there are actually contact points, so you should consider that there might be normal force acting between the balls in the same layer.
just as I say, because we're setting this in an ideal situation, so there won't be deformation. So that.
Okay. So do you think that? Okay. So after we discussed about the friction coefficient of the partial tower, can you tell me that? Is it possible that the tennis ball tower can be stacked with different balls per layer? And can you predict it? Like hexagonal tower.
Yes.
And how can you prove that different balls, for example, 4 balls per layer and 5 balls per layer can?
We didn't consider it because the different number of balls we did is set.
So you cannot predict, and can you?
We can predict if we take this shape into our presentation, and we will calculate out the sign phi and know where it's going.
And can you predict the boundary condition of gap between the balls? Okay. So the opponent still thinks that if you didn't consider the normal force between the same layer, it might cause deviation for every calculation inside your theory, because you should consider the minimum energy that might act between the balls. So do you think that the parameters, for example, friction coefficient of tennis ball and amount of balls in the same layers might influence the stability?
Yes.
And how will it influence the stability?
Just as I said, stated in the presentation, the coefficient of friction will decreases when the normal force increases. So that will makes the limitation to be lower than our theoretical.
Okay, time's up.
Okay, thank you. Okay, so for the discussion summary, first we discussed about how the friction and the normal force direction looks like and the structure. And we also discussed about the 3 dimensions in this part. And the opponent believes that the reporter should calculate the minimum strain energy that might act between the balls in the same layer. And because it might change the friction coefficient and change the gap between the balls, which the reporter cannot predict. And when the gap between the balls is changed, it might cause deviation. And for the parameters part, we discussed about how the different parameters such as friction coefficient and the different structures such as each bolt per layer and more structures will affect the stability of the tower. Thank you.
Okay. Thank you. Okay. The reviewer.
So my first question is, did you think that why your tower is lower than the theoretical value? Yours is lower than theoretical.
Because of the changes of coefficient.
But you say you only stack those 6 layers, but in theoretical you can go for that 13 layers, right?
Because the mass is not always the same.
Okay. And another question what I want to ask is, how do you test for stability?
We test this by it means the idealized or
Yeah.
idealized. We will calculate the equilibrium of torque and the forces just as I analyzed in our theory. And if it's determined in which one of this, and we think it is in an unstable condition.
And for opponents, what do you think? How to test the stability?
I agree with the method of the reporter.
Okay. My another question is, I think when we use a ball to collide the tower, is that 3 layer will be more stable or 4 layer will be more stable? What do you think?
We think the 3 will be more stable.
And what do you think?
I believe that 3 bolts per layer would be stable too, and I also believe that the reporter should consider the deformation and the minimum energy to have a more correct theory.
And I want to ask, why do you think that 3 layer is more stable? Because the normal force is bigger, so the maximum friction should be bigger, right?
I'm sorry, can you do that?
Yeah, it's okay. Because, okay, that's okay. Next question. And how do you make sure that the tower is not in the maximum stability of the tower?
We measured it by the sine phi, which we defined in our presentation, and if it didn't smaller
Okay, time's
than
up. Reviewer, you have 2 minutes to prepare your report. Okay, reviewer, please take the floor.
So I'm the reviewer from Kindergarten Church, and here I will talk about the tennis ball tower. And first, I will talk about advantage of the report. As reporter, they give us a good explain and clear presentation, and also a good PowerPoint. And for opponent, he also did a great job. He gave us a clear report, and he proved that the angle is differences, and here is his report. Opponent's question. Well, the first question he asked the.
Okay, stop the clock. Okay, resume. Okay.
So here's the summary of the reporter. He let me understanding the stability and different numbers of tennis ball tower, and he told us that the force will influence the tower is friction, normal force, and gravity. And to balance the tower, we have to reach two conditions: static balance and balanced moment. And this is the merits and the possible next step for the reporter. And here's our summary of the portion that he told us that the angle between the tennis ball will change over time, over the years, and he told us 3 dimensions, and he calculated the minimum state energy per layer gaps between the balls would change, and more structure should be tested. And this is the merits and the possible next steps for the opponents. And here's our discussion that opponent asked which friction coefficient affects the more. The reporter's response is the friction between the balls, and we agree the reviewer's view that we think that the friction between balls will affect the most. And opponent asked will the included angle change when the tower goes higher, and reporter says it will. And we think that the included angle will change as tower goes higher. And this is my first question: what is the parameter that determines the numbers of balls per layer and the stability? And reporter said it is because the mass differences, and we think that the size of the ball also will influence the tower, because once the ball size is a little bit different, it will cause the gaps to forming, and once the gaps is forming, they will make a friction and cause the unbalancing of the charge. And my second question is how many numbers is more stable, and report while we use the ball to collide the tower. Reporter said 3 layers, opponents agree with the reporters, and we also agree with the reporters, because we think the inertia is different. Once the inertia of the upper ball is bigger than the inertia of bottom ball, so it will cause a tilt and it will let the tower to collapse. And another question I ask is another question I ask is the stability of the tower in experiment. The reporter said that it will change the friction, and opponent agree with the reporter, and we think that we can use the earthquake simulator to test the stability of the tower, and we also can use floor to collision to test it. So this is our general suggestion and my presentation. And here's my. Thank you for this.
Okay, reporter, you have 2 minutes to summarize your concluding remarks.
So here, I'm going to start with the concluding remarks. So firstly, there shouldn't be normal force between the balls and the same layer. Since the normal force are pointing outwards and the coefficient of friction is smaller than 1, and so they will counteract themselves. So, and secondly, according to opponents' suggestions, we can improve by considering more about the deformation of the tennis ball, since the texture, since it's not a total rigid body that. Okay, and next, we think that the graph in the presentation has already clearly showed the directions of the force, which the opponent may not fully understand. And fourth, we're discussing about the idealized situation. So the formation can be gotten rid of the tower in our theory. And lastly, we think that the tower, in response to question, we think that the tower could stay stable with different balls per layer, as long as it is made up of a base of 3 balls it's made up of the base of the 3 balls. If the 6 balls or the 9 balls, it will stabilize itself because it can form a triangle. So, and it's the end of my remarks, and thanks for this.
Okay. So, any questions? Withdraw.
So the first layer has 3 balls, and the second layer has another 3 balls with different orientation. How about the third layer? Does the orientation come back to the first layer or not?
It will only contact the second layer.
Yeah, I know, but the orientation between the first layer and the second layer is 60 degrees, right? There is a difference. Because you have to put the second layer on a different, not on top of the first layer, but there's a rotation. And how about the third layer? Does it come back to the first layer or not? Do you have some photo of you? Yeah, so it looks like it comes back to the. So if you look at it from above, then it's at the same location. So how do you get on page 11? How do you get the number 13 from your analysis?
And we calculate the sign by
Let me ask you a different way. If you change the mass of the tennis ball or the friction coefficient of the tennis ball, how would it change the maximum number?
Yes, it will change the maximum, and it will change. It will change the normal force and the friction. critical value of sign phi will also change.
Do you have the data for the mass or the friction coefficient? If you do not have the data, then how can you get the number 13?
We have calculated it, but the calculation process is too complicated and it is very fancy, so we didn't put it on.
How about introducing the maximum? How does the maximum number depend on some parameters? Have you done this calculation?
No, I believe that the included angle will change in different layers between. Yeah.
And I think that the maximum layers depends on the coefficient of friction because it is about the torque to balance the torque to that the torque won't be collapsed.
What about the mass?
And yes, we also think that the mass will cause the stability because once the mass is bigger, the static friction will also become bigger.
Questions?
My question is for the reporter. How do you think if the thermal force will influence the coefficient of friction or not?
Yes, we think it will change because the surface of the tennis ball will be flattened and be more volatile.
How about you?
When you want the tennis ball tower to become an equilibrium system, then when the normal force changes, the friction changes because you need to balance the forces.
Yes, we also think that the normal force will influence because the normal force is tilt and it will change. It will component horizontal. The component force is a horizontal force, so it needs the friction that is stable. So the normal force is extremely important.
Okay. So please prepare your marks. Ready? Okay. Please show the score for the reporter. We got 5, 6, 6, 6, and 6. And for the opponent, 7, 6, 7, 7, and 7. And for the reviewer, 6, 6, 6, 7, and 6. Okay? So that concludes this round of 5. We have 10 minutes for break.
你现在没打算
15 minutes for break.
这上面要打，这上面要打。